In this tutorial, I'm going to show you how to simulate a simple reservoir with an inflow that changes over time and also an irrigation requirement that pulls water from the reservoir. When you run this model, it looks like this. This is the model we're going to create today. All right, so starting from scratch, this is a blank GoldSim model. And what we can do is add elements in the graphics pane here. So I'm going to start by setting up the simulation settings. I want my model to run. I'm going to go up here to simulation settings. I want it to run for a calendar period. So I'll change this to calendar time. And I'll set the start date to be January 1st, 2018. I want the model to end January 1st, 2019, so that it runs for a full 365 days. And I want it to have a 1-day time step. We can also change that here to be specifically days and how many days. We'll just say 1 day, that's the same thing. Then I'll click OK. Now what I want to do is set up the element that will act as the reservoir or simulate the volume of water in the reservoir. So I'll go up here to insert a stock element. I'll add a pool. All right. So we need to put in the ID. I'll just call this reservoir. And then I want to put in the quantity units. For this model, I'll be using megaliters. The flow units for this model will be liters per second. Okay, so for this model, it's a fairly large reservoir. We need to specify what the starting water volume will be, and then we can also put in upper and lower bounds that we want the reservoir to operate within. Instead of specifying the values here, I'm going to use another element called the data element that I will reference in these input fields. So for now, I'm going to leave these as is and then click OK. So I'll go up here to add a new kind of element, the data element. That's an input type. I'll put the data element here and I'll call this one V init, which stands for initial volume of water in the reservoir. And that's megaliters as well. And then this amount, I want this one to be 12,800. When I type that number in GoldSim already knows my display unit and it will assume that unit to be appended to that number. I click OK. And now I want to create 2 more points. I want to have the minimum and the maximum volumes that will cause us to control the reservoir to be within those 2 volume amounts. So I'm just going to copy and paste this data element. This one here is going to be Vmin. That is the minimum allowed volume in the reservoir, and this one will be this one is 11,000. The next one will be the Vmax. This one is maximum allowed volume in the reservoir. This number is going to be 13,000. All right, with that data, now we are ready to reference those data points in our reservoir element. So initial quantity, it's simply V init. You can see I just started typing it. As soon as I start typing, GoldSim will look through the model for any element with that name. Vmin. As soon as I find it, I can click on it, or I can just hit Tab key to complete. The Vmax will be our upper bound. So currently it's set to not have an upper bound, but I want it to have one, so I'll check the box. And now put in Vmax. I can also right click in here, of course, and browse the model for the element graphically. This is useful for a large model if you don't remember the name. Okay, and you can see that when I create these references, GoldSim automatically draws what are called influence lines here. These lines can be moved around as you wish. When I run this model, you can click Run up here, Start Simulation. When I run the model, I can look at the information about each of these elements, including its value and its actual result at the end of the simulation. You can see down here at the bottom it says the model ran through January 1st, 2019. That's the end date of the simulation. And you can see here that its value is 12,800, which is the initial volume. I can also right click and select a time history result. This shows me through time its value, and you can see it has not changed because we have not done anything to this reservoir over time, which is now what we're going to do. I need to change this model back to edit mode so that I can make another change to it. In this case, I want to add an inflow and an outflow. So to do that, I click on the edit mode button up here, and then select OK. You can see that the bar changed down here at the bottom to blue, indicating that we are now in edit mode. We can make changes to this model. The next step is to add a time series element, and that's up here in the data category again, time series. I'll put that over here and I'll call this inflow, and I'm just going to append a TS there to make sure that everybody knows that when they refer to this that it is a time series type element. Okay, the next step is to add a display unit. I'm going to keep with my liters per second here. Note that GoldSim is doing all of its calculations in SI units, and then it converts results to present them back to you in the unit that you specify in the display units input here. Okay, for now we're just going to locally define this data, but we could in the future, and we will actually in a future tutorial, make a connection to Excel by selecting this option here. But for now we're just going to edit the data locally, and I'm going to do that by copy and paste from Excel. So I'm going over here to MS Excel, and I already have a file ready to go with input data to define our inflow to the reservoir. And this is, you can see it has a column of dates and inflow in liters per second, and that's exactly what we want. So I'm going to select this data and copy it to the clipboard. Copy, and then I'll go back to GoldSim, and I'll go in here, edit data, select the first cell and hit paste. Notice up here it says the time unit is calendar data as opposed to day, which would just be a count of the days, but we want the actual calendar month dates to be specified in this time column. You can see that the value column here also has units of liters per second. All right, with that data in there, then we can go ahead and click OK. Note that if there were any blanks in any of those cells, that when we try to click OK, that GoldSim would tell you that there is a problem. So it actually walks through the data set prior to running the model to make sure that it's valid. Okay, the one important thing about this model, however, is that you need to make sure that the dates shown in this time series cover the range of the dates of the simulation. So our simulation runs from January 1st, 2018 all the way through January 1st, 2019. So this will run okay, but if I did not extend the time series through this date, the model would not run. And that's because of the way that the time series is represented. This is all advanced for a future tutorial, this information here. So just we'll go ahead and work with what we have. Now I want to add the time series inflow to this reservoir, so I need to go back into this reservoir, open up this the properties here, and you'll see that there are two tabs. There are two more tabs. One that's called Inflows, one that's called Outflows. Obviously, I need to click on the inflows to add the inflow. So then I just click on Add, and I browse the model for the time series and find that, put that in, and now I can click OK. And now let's just run the model to see what happens. Run the model, we get this this warning message, and this warning message, if I click yes, you'll see it'll open up a notepad or a text file, and it will say down here that the warning and the warning that we got in this run is that it's telling us that the pool element is overflowing. There's nothing linked to the overflow output. In other words, Now that we have an inflow coming in, the reservoir rose up to a volume that hit the upper bound, and therefore causes an overflow output on this reservoir, and we have not connected it to anything. So it's a way to prevent us from allowing an overflow to disappear into nothing, and to make sure that we complete our water balance in this model. Okay, and so if I just click on right click on this element, I can click on time history result, and you see that the reservoir volume is increasing over time until it hits the upper bound at 13,000 and stays constant at that level. If you click on the output port of any of these elements, you can look at the outputs. In each of these cases, these are data elements. They're very simple and they only have one output. The time series has a couple of outputs, one of those being the value that it records over each time step. And then the reservoir has many more outputs, and these are all based on the inputs that we provided it. There's also an outflows container, and that means we can have multiple outflows initialized in this model. Currently we only have one, and it's by default called outflow, and it has 0 requests being made, so there is actually no outflow at this time. However, the one that we want to look at is this one called overflow, and that's what we need to link to so that we don't get that warning message when we run the model. So now I'm going back to edit mode. I'm going to add an overflow element to the model that just references this one output of this pool element. So I'll go up here to edit mode, click OK, and then go to the function category and click on expression. And this is just a reference. This is all I'm doing, is calling a reference here called overflow from the reservoir. And this will be again in liters per second. And now I just need to reference reservoir complete by hitting tab and then hit dot. And this is a secondary output from the reservoir. So I'll just click on reservoir dot overflow. And now when I run the model, we should not be getting that warning, and we don't. There's the overflow occurring. You can see that during the time that the reservoir is filling, there is no overflow. And then as soon as the reservoir hits its upper bound, then it begins to overflow. And this is the net inflow, which in this case is just the same as the inflow. Okay, so now that we're here, now we can add an outflow in addition to the inflow. So I'm going back to edit mode. I'm going to add one more data element here. I'll call this irrigation demand. Demand for water from the reservoir to service irrigation requirements. And then the units here, again, liters per second. And for this model, I want this irrigation demand to be 125, or let's actually make it 175 liters per second. And now I go back to this pool element, click on outflows, and now I want to put that request here, irrigation demand. I'm just referencing it. You can see that created a link here. And now I want to give it a name that's useful. I'll call this irrigation. Click OK. And now if you look at the outputs of the reservoir, you'll see that in this folder called Outflows, we have this called irrigation. So I want to reference that as well. So I will put another expression in here and call this irrigation supply, water supplied for irrigation from the reservoir, and units of liters per second again. And now I'll just reference, I'm going to do this via right click. So I'll right click here, insert link, and browse the model for a secondary output of the reservoir. I don't want the volume, I want the outflow. So I'll click on this to expand again, click on irrigation. Now that that's connected, click OK. Now we can run the model. And I can look at the reservoir over time, and you can see that it drained down because of our irrigation demand. It rose up, hit the upper bound, drained down again until it hit the lower limit of 11,000. So instead of just creating these temporary charts like I've been doing, instead I want to create a chart that lasts so that I can just double click on it and not have to recreate it every time. So up here in the results category, I'll click on time history result. And now I just need to add the results that I want to see. First of all, I'll call this a reservoir time history. And then I want to add some of these outputs. I'm going to add the irrigation supply and the inflow to the reservoir, and that's also an output on this reservoir. I could either link to the time series itself or the total inflow of the reservoir. If I have multiple inflows coming in, maybe that's what I want to see. So I'll click on total inflow, and and then I want to click on the reservoir volume itself. And then one other thing is the outflow, the overflow, I mean, sorry. Okay, now these names could be changed just a little bit to make a little bit more sense. So irrigation supply, inflow, reservoir volume, overflow. That already makes sense. Okay, now that I have all of those, I can simply double click on this chart and it shows me everything. So it shows me how initially the reservoir is drawing down because the irrigation demand is greater than the inflow. The reservoir now begins to rise up as the inflow increases above the demand, and then we hit the upper bound and we see this short period of overflow, and then once again the inflow draws down below the demand, therefore the reservoir draws down until it hits the lower bound of 11,000 megaliters, and at that point the demand is only equal to the inflow. These lines are on top of each other over here. We can show that by changing the width of the red line. Go to the properties, change the width, and you can see that the red line is underneath the green line right there. Okay, so this concludes the first part of the water management tutorial, and thank you for watching. And if you want to see how we continue with this modeling effort, go ahead and find our second tutorial, in which we will add some logic on determining when we want to apply the irrigation demand. So we're going to have the irrigation demand turn on and off based on the time of year in which irrigation will occur. Thanks for viewing.